Let's give you a quick summary of all the function transformations. So let's look at the first one here. Any function, let's define f of x equals x squared, which will look like this. This thing here, negative of the old function, would be you turning it upside down, because if you look at 2, f of 2 would jump to 4. So this here would be 4. But then when you look at this, f of 2, the old stuff, this is the old stuff, f of 2, with a minus in front of it. So the old stuff was 4, but because of this negative, it becomes negative 4, so it jumps down here. So in effect, this transformation would just turn the graph upside down. That's why it looks like this. So now the next one, let's say you have any function, f of x equals x squared, which looks like this. When you apply this transformation, it moves in the opposite direction. So now this transformation will look, this transformation here, this transformation with the negative 2 inside the brackets would move it across by 2. So if you have plus 2 like this, it will move it to the left by 2. So this will now, it always moves in the opposite direction. Anyway, next one here. Any function f of x equals, let's just say x squared, which looks like this. This transformation here would mean the old graph drag everything down by 1. So normally f of 0 would be 0. You take away 1, so it gets dragged down. Normally when you look at 3, f of 3 would be 9, but then you drag it down by 1. So it would be at 8, and then you basically drag everything down by 1, so it looks like this. So this transformation drags the function down by 1. All right, let's look at this next one here. Let's look at this one here. Let's define a function. It could be any function. I'm going to use this one. If you know this function, you know. If you don't, then you don't. All right, there's this function called sine of x, which looks like this. This is 360, this is 180, this is 90, this is 270. If you know it, you know it. Okay, this transformation means the old graph, which is our sine graph, times everything by 3. So when you look at 90, it's at 1, and when you times it by 3, it jumps up to 3. It jumps up to 3. 3. When you look at this, sine of 270 is negative 1, but when you times it by 3, it becomes negative 3. And then when you look at this, f of 180 normally is 0, but then when you times it by 3, it stays 0. So our graph here is 0 times 3, it will stay at 0. Here is 0 times 3, it will stay at 0. So our new function would pass through here, 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 negative 3, 0. So it looks like this. So this transformation drags everything out by a factor of 3. So if you have something like this, if you have f of x equals x squared, this 3 thing would drag everything up by a factor of 3. 0 stays at 0, so it just looks steeper. Okay, it looks steeper. Well, anyway, this here drags everything out by a factor of 3. Okay, now this one here, let's say you have f of x equals x to the power of 3, which looks like this. With a minus in there, it flips it like this. So now this transformation will flip the graph along the y-axis. So it will look like this. Okay? So that's your summary.